Hi, we start intro to nonlinear regression models now. Should be several lectures over the next couple days. So first, just the introduction. All right, so um, I think the best way to start is just to see the similarities between nonlinear and linear regression models. So both, let's write both linear and non-linear regression models, they have the same form. Are yi equals f. Let me write xi here. And here I would write some parameter thing. So here I'm going to write fxi. If it's linear, I'm going to write beta. And ei, and this will be for linear. And this is more a matter of notation because we call the linear parameters beta and the nonlinear ones gamma. Okay, so this is linear. And yi equals f xi gamma plus epsilon I, and this is nonlinear. Okay, and here f is called the regression function. And in the linear case, it's linear. Guess what? It's linear. In linear case, f xi beta is just equal to a linear function. So this would be equal to xi transpose beta, where xi is defined as this column vector here, 1, xi 1, xi p minus 1, and beta is beta 0, beta p minus 1. So I take the so that just tells you that that's just, so in the linear case, so yi equals just our good old form, 1 times beta 0, right? Xi 1 times beta 1. So is beta 0 plus beta 1, xi 1 plus ... plus beta p minus 1, xi p minus 1 plus epsilon I. Just like we've been doing it. But the nonlinear one, while in the nonlinear case, okay, in the nonlinear case, f, guess what? F is not a linear function. Okay, so do you know the definition of a linear function? So here I have, so this means linear in beta. So I start with a function. I'm thinking this is a function of beta where these are just constants. And I end up taking a linear combination of beta here. So what I'm saying, in the nonlinear case, I cannot write this as a linear combination of gamma parameters, okay? So that is, so how would we say that? So i.e., so this means for gamma equal to, say, gamma 0 to gamma p minus 1. Fxi gamma is not equal to the sum. Let's say k equals 0 to p minus 1. And I'm going to call this C, ck, xi, and gamma k for any functions c, k equals 0, p minus 1. In other words, I can't write this as a linear combination of the gammas. So it's something else. It's something else. So we should probably look at examples. Oh yeah, a few more comments. So let me get another piece of paper going. So in both, so what should we call it? Yeah, we'll call this one or linear and nonlinear. Okay. So in both L and NL, we assume IID normal 0 sigma squared. So that's the same. Okay. So that's the same. So they look almost exactly the same. Except I know I can write this as a matrix X times a vector B. And this, I don't see how, I don't know that I can do that, okay? This is something else. All right, we're going to start with very simple examples where, in fact, we only have one predictor because you can go from there, but it will help reduce the notation. You'll get the general idea, and actually a lot of examples are like that, so even probably real models. So let's maybe look at an example here. So I've got some notes here. I'm not copying them though. So let's look at some examples, I suppose. Yeah. So some examples. And let's play the game linear or nonlinear. Okay, so what about, suppose I have log yi equals beta 0. Now that should give you the hint, right? But you can't just tell by the letters. Plus beta 2, beta 1, I'm sorry, beta 1 xi1 cubed plus beta 2 xi1 xi2 plus epsilon I. Okay, this is a 1. Well, I wrote the betas, so you could just say it's linear based on that, but no, that would not be correct. We can think of this as a transformed linear model. I do have this log of yi, but that's just another vector, yi, right? There's nothing changed with the form here. So if we just think of yi prime equal log yi. And then if you like, you can think of xi1 cubed as xi1, if you want, prime, and xi2 prime, xi1, xi2. Okay, and now you can see you just have yi prime equal beta 0 plus beta 1 xi1 prime plus beta 2 xi2 prime plus epsilon I. Okay, so all I do is change things in the data set. Okay, I didn't change anything about a model, and I have a linear model now. So this is a linear model. So this is linear. Yeah, the important thing is that if I start here and I assume epsilon is normal, right? Normal, 0 sigma squared IID, and I come and make these changes, this does not affect the epsilon term at all. It's just still stayed here. These are the same vectors here. So it is a linear model. It's just we wanted to do some operations on the vectors in the data set first. Okay, so it is a linear model. Notice epsilon I is still normal 0 sigma squared. So that's important too. So note. Even after this transformation here. Okay, what else? Let's see what else would be another one to do. Now, maybe time for a nonlinear one. Suppose I have, so A. What if I have yi equals gamma 0 e gamma 1 x I, and I won't put a, sorry, I won't put a 1 there because this is like simple linear regression, right? I just have a single predictor variable and plus epsilon I. So in this case, can you write it as a linear model? So we could try. One thing I know is if I take the log here, this will separate out. So try taking the log. So is it linear? So these are examples, linear versus nonlinear. Okay, so if I try to take log of each side, that's gonna give me an equality, right? Of each side. But what's the problem here? Well, you could take the log of the regression function, that's fine, but you're screwing up the error. So if we try to do this, we get log yi equals log, you can't do anything here, okay? So it's log gamma 0 e gamma 1 xi plus epsilon I. This does not reduce to anything, okay? So sometimes, however, not linear, okay? Definitely not linear. The error is no longer independent, standard normal. It's now sort of absorbed in here if you do this. You can write if you are willing to understand that the error has changed, you could write the regression function in a way that's linear and then sort of try to fit the model again, understanding that the error function, maybe it would help even, you know, maybe it's meant to be a linear model and you've tried to model it with a nonlinear model. So you could do this. You could still try, log yi equals, taking the log of this side, I get log gamma 0 plus, take the log of this, I get gamma 1 xi, and let's just say this. So you could try this plus epsilon I. This is different. This is not just taking the log of this model. So this model is not linear. This model's linear, okay? Sometimes when the regression function can be converted into a linear form, you call this intrinsically linear. But I don't want you to get confused about that. This one's nonlinear. This one is linear. So this is linear, but it's a different model. I got to stop and I will click into the next video. All right, thanks.